Are you tired of failing your organic chemistry test? Struggling with grasping all the daunting tasks of nomenclature, or feeling overwhelmed by the amount of memorization? Well, memorize no more. Turn that F into an A with the help of our new program, Nomenclature Made Easy.
Today we will be discussing the topic of International Union of Pure and Applied Chemistry, or IUPAC nomenclature for alkanes. Naming is one of the most important skills to have in organic chemistry because there are millions of known compounds and scientists must have a set of standards for identifying each. Once you understand the nomenclature rules and how to apply them, you can name pretty much any molecule you come across. We're beginning the lesson by using alkanes because they make up the simplest organic molecules and are a great place to begin applying your skills in nomenclature. So to start off, we will discuss the basics of nomenclature in general. Firstly, all names of alkanes end in the suffix -ane. The prefixes for alkanes with 1, 2, 3, or 4 carbons have historical roots, while the alkanes with 5 or more carbons are derived from Greek meaning. To help you memorize the first 4 roots, we will use a common mnemonic device that may help. Try to remember that Mary eats peanut butter. This corresponds to methane, ethane, propane, and butane, where methane refers to the structure with 1 carbon, ethane refers to the structure with 2 carbons, propane refers to 3, and butane refers to 4 carbons. Knowing the roots for the Greek numbering system makes it easier to understand the following roots, where hex refers to 6, hept to 7, oct to 8, and so on. And to make things easier, we've put a table on the board that shows a list of all the names corresponding to the number of carbons and structures that they have. Creating a table like this in your notes will be useful for future reference. For the straight chain or unbranched alkanes, following a couple of essential steps will lead to correctly identifying the molecule. Firstly, you must identify the parent chain, which is the longest chain of carbons in the molecule. Since we're starting with a straight chain, the parent chain is the only chain available. So, how many carbons does this chain have?
You there, student.
6 carbons. Once you've numbered the carbons on the chain, match it to the prefix given by your table. Then end it with the suffix -ane. Which prefix matches the 6 carbons?
Hex.
Yes, 6 carbons means hex, and then ane. There you have it. The naming of unbranched alkanes is the easiest type of alkane, but now we get a little bit trickier. Sometimes molecules may have the same molecular formula, but different chemical structures, which are known as isomers. Branching makes the nomenclature of these molecules a bit more difficult, but they can still be named systematically. By following along with our 4 essential steps, as well as the examples used along the way, you will be able to name branched alkanes. Number 1, the first step is to identify the parent chain, remembering it is the longest chain of the molecule. It is important to notice that often the longest chain of carbons is not simply the carbon that flows from left to right, but the one that snakes around the molecule. Using this example, you can see that the parent chain snakes all along the molecule and ends up being 8 carbons long. Once you have identified the longest and most correct parent chain, match the number of carbons to its corresponding prefix and add ane. What corresponds to the carbon on the parent chain?
Yes, you, ma'am, with the incredibly low hand.
I believe it's octane.
Yes. The second step is identifying and naming all the substituents that stick off the parent chain. Substituents are named in the same fashion as the parent chain, except they end in the suffix YL instead of ane. This indicates that they are a group connected to the parent chain. How many groups do we have branched off the parent chain?
Yes, you, sir.
3 methyls?
Yes, 3 methyls is correct. In this example, we have a total of 3 methyl groups, and that corresponds to trimethyl in the IUPAC name. Some substituents have common names and must be memorized, but we will only focus on the IUPAC system that is internationally accepted. The next step in this process is ordering the substituents. Beginning at the end with the most substituents, all carbons attached to the parent chain are given a locate, as you can see here on the board. Where are our 3 methyls? Locates 2, 3, and 4. Exactly. Now that we have them numbered, we will place commas in between all the numbers since all three groups are methyls. When writing the IUPAC name, we place dashes in between numbers and words because all three of our groups are methyls. Then we write in our name, trimethyl. To sum it all up, our IUPAC name for this molecule is 2,3,4-trimethyl octane. And that's how you name branched alkanes.
Look inside your tiny mind, then look a bit harder, 'cause we're so uninspired, so